Welcome back. In this lesson, we're going to be looking at the operation of a compiler and an interpreter, including how high-level language is translated by each of those and how errors are reported. We're also going to be looking at the advantages and disadvantages of a compiler and an interpreter. So let's begin. First, we're going to start by defining what a translator is. A translator is a type of software that converts code written in one programming language into another, usually a high-level language into a low-level language. However, we convert assembly language using a translator called assembler, and that converts it into machine code. So that's also possible. And computer programs can generally exist in several forms. And these are normally written by humans in a form that people who are trained as the computer programmer can understand. In order for this program to be useful to other people, it needs to be translated into binary instructions so the computer can run this particular code. Humans find it very difficult to read binary. Hexadecimal might be a bit easier, but computers can only perform operations which are written in binary, so even hexadecimal needs to be converted to binary. A program, therefore, must be translated into binary before a computer can use it, and this is done by a utility program called a translator. There are several types of translator programs in use. Each one performs a different task. We already know that a program written in assembly language uses a translator called an assembler, which converts the instructions into machine code for the processor to run. However, there is a special type of translator called a compiler, which translates a program written in high-level language into machine code, so it can be directly used by a computer. Now, once a program is compiled, the machine code can be used again and again to perform the same task without recompiling it. A compiler checks the entire program before compilation and either turns it into machine code or outputs a list of errors that it's found in the code. And this is useful for whole system tests or when the program is actually complete. It produces an executable file which can be distributed to others and does not contain the original source code. So it supports the programmer in protecting their code. Now, if you look on screen, the high-level program statement sum is equal to first number plus second number becomes the following machine code instructions when translated. And it's very difficult to look at those instructions and work out what the program is trying to do. But it's a lot more easier to work that out by looking at a high-level programming language. Now, interpreters and assemblers are other types of translators, and we talked a bit about assemblers, so we're going to look at that in a bit more depth. So let's start with interpreter. A computer program that reads a single statement from a program written in high-level language, performs that particular action, and then moves on to the next statement is an interpreter. So this is used while we're developing a program and it goes line by line. So chances are that if you ever use Python to create some code, you're using an interpreter. The difference between a compiler and an interpreter is that the compiler will check the whole program and produce an executable file or produce a list of errors, whereas an interpreter will just run the code line by line, and if there's an error, it will detect it immediately. So interpreters are used in program development, whereas compilers are used at the end of that particular cycle. Assemblers are special computer programs that translate entire programs written in assembly language into machine code. And this machine code can be directly used by a computer to perform a required task. However, they work line by line and they translate line by line rather than the whole program as a compiler would. So they're kind of like a combination of an interpreter and a compiler for assembly language in a way. Now on screen, you will see a comparison of compilers, interpreters, and assemblers on 5 different strands. So we look at the function, that's translation of high-level language program into machine code. Interpreter executes a high-level language into machine code a statement at a time, and assembler translates a low-level language program into machine code. Compilers produce an executable, assemblers produce an executable, but no executable is produced when an interpreter is in action. Compilers and interpreters work with high-level languages, whereas assemblers work with low-level languages. Compiled programs are used without a compiler as there's no need for retranslation, but you need the source code with an interpreter. So you would need to give somebody their source code if you want to use an interpreter, which means that there could be some copyright issues in the future since they have your source code. Assembled programs can also be used without the assembler, so no need to share source code there either. And finally, compilers and assemblers, you can distribute the program for general use, whereas with interpreter, it's only used when the program is being developed. So what happens when things go wrong? As programs are written by humans, they contain errors, and there are different types of errors. The most common is a syntax error where the program statement doesn't obey the rules of the programming language. For example, in Python, you're trying to type in print, but you accidentally typed in PRNT and you missed the I, and that means that the program won't execute. Or you might miss a bracket or a comma or a colon or something like that. A program cannot be translated if it contains syntax errors, so it won't fully execute. The second type of error is a logic error. This is where a program doesn't do what the programmer wanted it to do. So the language and the syntax might be correct, but there's a mistake that's been made in the logic of the program. The program can be interpreted and compiled, but will result in errors or a crash if there is a flaw. For example, division by zero, or you're trying to get two inputs, but you only coded the first input and the second input isn't asked. So a syntax error is where a program statement doesn't obey the rules of the programming language. The program can't be translated if it contains a syntax error, so you need to fix this. When a program is being compiled, if there are any syntax errors, you won't generate a translated program, but produce a list of errors in the entire program. The programmer then needs to correct all of them and recompile the program, and that is a very slow process. When a program is being interpreted and you encounter a syntax error, you find that error in that particular line. So you can fix that before you move on to the next line. The programmer is alerted to where the error is, and then the error can be corrected. Interpretation, therefore, is very useful when we're developing program. Logic errors, on the other hand, are very difficult to work out because they make the program not do what the programmer intended it to do. So these are often called bugs. Logic errors are found when a program is actually run. And when a program is being run and it doesn't do what it's supposed to do, that's a logic error. And you can find these out generally by tracing the program using trace tables and using test data. So you say, well, okay, I want to enter 5 and 7, and that should add the two numbers up and give me 12. But for some reason, it's giving me 13. There's something wrong with the program. So trace tables are commonly used to detect logic errors. Now on screen, you can see a program in Visual Basic and a trace table, and you should be able to probably work out what's wrong with it. Let's see if you can work out which of these pieces of code is written in a high-level language. Give one benefit of writing code in a high-level language. Give one benefit of writing code in a low-level language. High-level languages can be compiled or interpreted. Give two differences between a compiler and an interpreter. So it should be fairly obvious that the first one is using mnemonics because that's like STA, ABC, INX, short form of instructions. So that's probably written in a low level language, whereas the for loop one is quite clearly a high level language. It's very easy for us to understand. And that's perhaps one of the key benefits that humans can understand high level languages very easily. We can fix errors quite quickly in high level languages. Writing in low-level languages means programs tend to be more memory efficient because they're closer to machine code rather than high-level language. And two differences between a compiler and interpreter, you can pick them up from the table earlier. That's the end of this lesson. Hopefully you should be able to answer what the purpose of a compiler is, what the purpose of an interpreter is, what the purpose of an assembler is. You should be able to compare the use of translators for program development, which one is useful at the end of the cycle and which one is useful during development. You should also be able to explain the two types of errors that might occur whilst programming, both syntax errors and logic errors, and give examples of those. That's all for this particular lesson. If you do have any questions, do get back to me. Otherwise, I'll see you in the next one.